Hello again, pinball fans. Butch Peel with Jersey Jack Pinball. Since the very first Wizard of Oz pinball machine, we've used commercial off-the-shelf CPU boards in all of our games. Although we set these CPU boards up at the factory to recover gracefully after every power down, they can occasionally have trouble booting up properly when a game is turned on. So I thought I'd make a quick video, show you how to jumpstart a CPU board and get your game up and running 100% again. Let's get right down to business. So how can I tell if my CPU board actually needs a jump start? Well, the biggest indicator, of course, is a dead playfield. No lights at all on the playfield to speak of. You might have a few controlled LEDs, 12-volt LEDs, like spotlights, things like that, that could possibly be on. But all of the feature lighting and underneath the plastics, everything will be off. Any small monitors, like the crystal ball on this game, Willy Wonka, the Wonka Vision, the book LCD on Hobbit, things like that, will be non-functional also. They'll be blank screens, as well as the large 27-inch in the back box. But the most definitive symptoms by far will be exhibited on the I/O and CPU boards. In this game, both are located inside the metal box in the bottom of the cabinet. First of all, take a look at this end of the I/O board. All of the LEDs for the fuses, the 70-volt, 20-volt, and 12-volt circuits for controlled coils, LEDs, motors, and things like that will be lit up. However, the fan in the center of the CPU board, right over the processing unit, will not be spinning. And neither will the fan on the ATX power supply mounted elsewhere in the cabinet. If I sound a little vague with my location information, that's deliberate. The exact location of the I/O board and CPU board changes with some of our games. With early Wizard of Oz and Hobbit, the CPU and I/O board will be in this metal box inside the bottom of the cabinet. Wizard of Oz has so many different configurations. The location of the power supply and the type of power supply even changed over time. So early on we started with ATX supplies mounted outside the metal cabinet. We moved to a unified power source circuit board that would be in the front of that box. And then we changed later on again to a different type of ATX power supply that's inside that box. And now we're using, for the later ones, the same configuration as Pirates of the Caribbean or Willy Wonka, in that the ATX power supply is up in the back box or head of the game, along with all of the circuit boards. To gain access to the I/O and CPU boards when they're up in that back box, you'll need to first remove the back glass. The key is hanging on the inside of your coin door. Carefully set the back glass in a safe place, then unlatch the 27-inch LCD and swing it straight out and then over to one side. Next, remove the 4 screws holding the lid of the metal enclosure in place. You can disconnect the cable for the LED strip on the cover or tuck the lid up on top of the articulating arm, as I've done here. This will provide access to the ATX power supply, the CPU board, and the I/O board. It's important to note that your CPU board is not malfunctioning or defective when it requires this jump start to boot up the game again properly. Recall that this CPU board's primary application is inside a desktop computer equipped with a front panel momentary contact power switch to use to reset or restart the computer. We set up the basic input-output system, or BIOS, to tell the CPU to recover and power up normally next time whenever the power is shut off. However, sometimes the CPU interprets the power shutoff as a brownout or a dip or restriction in the source power. When this happens, the CPU works as designed to protect its circuitry and data by going into a safe mode, and it then requires a press of that front panel power switch to recover and reboot properly. In our pinball machine application, we don't have a front panel switch, so we have to perform this jump start to tell the CPU to recover and reboot our game so we can play. So, back to the CPU board in my Woz game. The first thing we need to do is locate the multicolored 24-pin power connector on the CPU. It's very large and distinct, and it has just about every color of wire running into it that you can possibly imagine. On one side of the connector, you'll see a green wire with black wires on either side of it. It's the only green wire in that bundle. This is the power supply on signal wire. The black wires are ground. In a desktop computer, this green wire and a ground wire would be connected to the momentary contact power switch on the computer's front panel. Here's a pinout of that 24-pin connector. We're going to simulate pushing that momentary contact power switch by temporarily shorting the green wire to one of the black wires on either side of it. The tool we're going to use is a simple paper clip. Make sure it's made of metal with no paint or vinyl coating on it. Bend the paper clip into roughly a U shape. Leave the two ends even with one another and close together like this. A quick tangent here to show what's inside a typical connector in your game. Most of the devices in a pinball machine are controlled in one way or another electrically. To make them easy to remove from the playfield, cabinet, or back box of your game, we place one or more connectors in each device's wiring, usually within a few inches of the device itself. Each connector has a male side and a female side that snap and lock together to make a strong physical connection that isn't easily pulled apart. Similarly, each wire in each connector has a male or female pin crimped onto the end of it. The pins snap and lock into the connectors, so on each side, wires, pins, and connector act as one unit. And the pins are what create the strong electrical connections between wires as the connectors are pushed together. They break the connections as the connectors are pulled apart. Printed circuit boards, like our CPU, are just another type of electrically controlled device in your game. We solder the pins of one half of the connector, sometimes referred to as a header, directly to the board. Traces on the circuit board take the place of wires on that side of the connector. Back to the jump starting procedure. The crimp pins inside the connector housing are pretty long, so the top portions that crimp to the wire insulation are actually accessible through the back of the connector. All we have to do to short pins together with our paperclip legs is touch the tops of them, like so. This allows us to short the two pins in our power connector together while the connector is plugged into the CPU board. All of this is going to require power, so make sure your game power is turned on. Then simply slide the legs of the paperclip down the green and black wires into the back of the connector, press down firmly, and hold them there until the CPU starts to boot. As soon as you short the pins together, the CPU fan will start spinning. Continue to hold the paperclip down firmly. The fan may stop and start again as part of the normal boot process. Keep the paperclip inserted until you see code beginning to load in the upper left-hand corner of the 27-inch LCD screen. This is your signal that it's safe to remove the paperclip. The fan should remain spinning and the CPU should complete its boot process on its own. And the next time you power up, the game should come up without you and your paperclip needing to intervene and assist. If you hold the paperclip in place for about 20 seconds, the fan is spinning but the game doesn't seem to be booting, that is, no code loading on the 27-inch LCD. The CPU may have had some unfinished business to complete from the last time it was shut down. Power may have disappeared before its safe mode tasks were complete. If this occurs, pull the paperclip out. The fan will likely stop spinning. Power the game down, wait approximately 30 seconds, then power it up again. See if the game boots up on its own. If it doesn't, reinsert the paperclip and attempt another jump start. Incidentally, there is another connector called JFP1 on this board that can also be used to jumpstart the CPU. People recommend using a screwdriver to short the two necessary pins together. However, the pins on this connector are very small and close together. There are also several similar looking connectors nearby on the board. With my old eyes, it's difficult to see which two pins to short together and to actually hold the screwdriver in place and maintain that short long enough for the game to boot. On top of all that, there's just something about poking a screwdriver around on a powered board that makes my skin crawl. Better to use the paperclip method. If your CPU failed to boot because its onboard battery died, you'll need to replace that battery. It's a CR2032, a standard 3-volt coin cell lithium battery readily available in local stores and online. Life expectancy of these batteries can vary widely. A good rule of thumb would be to replace your CPU battery in your game every 3 years. Obviously, it's best to replace this battery before it dies to preserve the factory BIOS settings. And you'll need to replace the battery while the game is powered on. There are detailed instructions for changing the battery in Section E of every game manual. If your battery does happen to die before you get around to changing it, you'll need to connect the USB keyboard to the game inside the coin door, then make and save a few changes to the default CPU BIOS settings. The most common settings you'll need to change include never pause on startup errors like no keyboard found, recover and reboot on power failure, and of course, USB should be first in the boot order above the SATA drive to accommodate our ISO full software updates. It's important to note that a dead CPU battery will only reset BIOS settings to defaults. There's no effect at all on your game settings, your high scores, and things like that. These are all safely stored on your solid state drive in a Jersey Jack pinball. However, it's not a bad idea to back them up periodically on a USB stick using the game's settings backup utility. As I said earlier, when the CPU is in one of its safe modes and doesn't seem to want to boot, it's likely interpreting the last power down as a brownout or dip in the source power. We've noticed that this seems to occur much more often when our games are turned on and off, along with several other games, using a circuit breaker or a power strip. In our games, these commercial off-the-shelf CPU boards tend to boot more reliably and consistently when the games are turned on and off using their own power switch, under the cabinet near the right front leg. If your WOZ has a large square circuit board mounted in the right front corner of the metal box, then your game does not have an ATX supply. It's powered by a Unified Power Source or UPS board instead. This board is equipped with a jumper that keeps the power supply on signal grounded all the time. This jumper is labeled J12 on the board and it's removable. If you're having trouble getting your CPU to boot on a game powered by a UPS board, power the game down and remove the J12 jumper. Power the game up again and watch the CPU fan. If it doesn't spin, perform a jump start with your paperclip tool across the green and black CPU power connector wires. If the game boots up, power back down and reinstall the J12 jumper. If the game does not boot up, also power down and reinstall the J12 jumper. But power up again and see if the game will boot up unassisted. Remember to wait at least 30 seconds between power cycles and boot attempts. Well, there are definitely a lot of things happening inside this metal box when you power up to get your game ready to play. Hopefully I've shed a little light on the CPU and its boot process in this video. Time to fold this game up and play some pinball. See you guys next time.